Hello all and welcome back to the Basics.Academy channel. In this video, we are going to solve the problem number of recent calls. You have a recent counter class which counts the number of recent requests within a certain time frame. Implement the recent counter class. Let us copy the question, go back to our AI Socratic interviewer, paste the question and get started.
Welcome back to the Basics Academy. Today's problem is LeetCode 933, number or recent calls. Before we touch any code, I want you to explain the problem back to me in your own words. So what is a recent counter actually counting, and what does a single call to ping do?
Recent counter is actually counting recent counter, new recent counter, dot ping 1, requests 1, range is given by t minus 3000 comma t, so it returns 1, then recent counter dot ping 100, 2 requests, range is minus 2900 200, return 2, then ping 3001, requests 3 request, range, return 3, then we have ping 3002, requests, ranges, request 4 requests, ranges 3000 ping and 3002, return 3. It is counting the number of requests in a time frame of t minus 3 function comma d, whereas the written part is not clear from the question.
Good, you've got the window right. T minus 3000 to t, intrusive on both 00 to t, intrusive on both ends. Let's clear up the return using the example instead of me telling you. The last call is ping of 3002 and the answer is 3, even though 4 happened in total. Which of the 4 pings is being excluded and why?
Which of the 4 pings? Adds a new request at time t. Adds a new request at time t, where t represents some time in milliseconds, and returns the number of requests that has happened in the past 3000 milliseconds, including the new request. Specifically, return the number of requests that have happened in the inclusive range t minus 3000 comma t. It has excluded the last ping of 3002 as we have to return number of requests that has happened in the past 3000 milliseconds, including new requests.
Careful, read your own sentence again, including the new request. So 3002 can't be the one excluded. Let me push on this. Possess say range is 2 to 3002. Through the 4 request times 1, 100, 3001, 3002, and tell me which ones fall inside that range and which one does not.
The first one is excluded. That is pinged of 1.
Exactly. 1 is less than 2, so it falls out of the window. The oldest request expires, not the newest. That's the whole shape of this problem. Now the input-output contract. This isn't a plain function, it's a class. What state does the object need to hold between calls, and what exactly does thing take in and return?
What state does the object need to hold between calls, and what exactly does ping take in and return? Ping 1 requests 1 ranges k range state does the object need to hold between calls. It must hold requests and the range. This is the these one, then we have t equal to 100. It need to hold the requests between calls, and ping should return the new range always.
Half peer is thermal pi sagising Pashchimi Afriki Rendinavian Leone. The state is the request's good, but you said ping returns the new range. Look at the signature again. It says in ping in t a range is 2 numbers. So what single thing is ping handing back to the caller?
Okay, in ping in the range is 2 numbers. So what single thing is ping handling back to the caller? Okay, the example itself return 1, return 2, return 3, return 3. Okay, ping must return the number of requests that fall between the range.
That's count an integer, not the range itself. Terminology precision like this is what stops you writing the wrong return statement later. Now constraints. There's one constraint here that is doing an enormous amount of work. It changes what you can get away with. Which one is it, and why does it matter?
Be constrained. This is the most important constraint because This ensures that each new t minus 3000 will be greater than the previous value of t minus 3000.
That's the one, and your reasoning is right. Strictly increasing t means the left edge of the window, t minus 3000, also only ever moves forward. It never goes backwards. Now push that one step further. If a stored request has already fallen out of the window once, can it ever come back into the window on a future ping? And what does your answer let you do with that request?
If it has fallen out on the window, it will never come back into the window since t is always increasing. Since t is always increasing. What does your answer let you do with that request? That request can be safely removed.
That's the key insight of the entire problem, and you got there yourself. Once it's out forever, so you can permanently discard it. Before approach edge cases, give me 2 or 3 concrete scenarios you'd want to be sure your implementation handles correctly. Think about boundaries.
The solution should handle. Let me check the constraints. E is greater than 1, less than 10 is to 9 at once, t is tilde 4 cos will be made to think. Handle the case of t equal to 1. Give me 2 or 3 concrete scenarios you want to be sure where implementation handles correctly. Think about boundaries. The solution should handle the case of t equal to 1. That's all I can think of.
T equals Pia Cloes thermal P hissing Pashchini Afriki Rendinavian Bioni 1. The window becomes minus 2999 to 1. So the lower bound goes negative. Good catch. But there's a nasty A1 hiding in the word intrusive. Suppose an old request sits at time 100, and now ping of Dunethane arrives. The window is 100 to 3100. Should that old request be counted or discarded, and which comparison operator gets that right?
Okay. Returns the number of requests that has happened in the past 3000 milliseconds, including the new request. Specifically, return the number of requests that have happened in the intrusive reach. T minus 3000 cover T. Suppose an old request sits at time 100 and now ping 3100 arrives. The window is 100, 3100. Should that old request be counted or discarded? It should be counted. Counted because it is intrusive.
It's counted because the boundary is intrusive. Now say that as code logic precisely. You'll be removing old requests in a loop. Complete this condition, keep removing the oldest request while its time is blank, t minus 3000, less than or equal to, and why does the wrong one break the case we just discussed?
Okay, keep removing the oldest request while its time is less than t minus 3000. If we keep less than or equal to, it will discard the above scenario that we just discussed.
Topan, fill peer litavra. Strictly less than. Less than or equal would evict the request sitting exactly on the boundary, which is inside the window. That's the off by one that bites most people here. Now approach. Start with brute force, the dumbest thing that works. If you stored every single pin, never threw anything away, how would ping compute its answer, and what's the time complexity per call?
Okay, how would ping of the compute its answer and what's the time complexity per call? So brute force, we add everything into an array. For each ping, we would store requests in request array and then iterate the request array and compute the range, and if request of I is less than t minus 3000 comma t, we discard get request or we don't increment the counter in this case, else we increment the counter and at last we return the counter. Time complexity will be big O of L and space complexity will also be big of L because requests are stored in requests array and we will be on the worst case require big O of n time for processing the input.
That one precision note, order n is per ping call. Across all n pings, that's order n squared in total, worth saying explicitly in an interview. Now optimize. You said expired requests can be permanently discarded. Think about where things enter and where things leave. New pings arrive at one end, expired ones leave at the other. What data structure is that describing?
Queue. Queue data structure, because in queue we add at the rear and remove from the front.
A QFIFO, NQ at the rear, DQ from the front. That's exactly the access pattern this problem hands you. Now walk me through ping of T step by step using that queue in plain English, no code yet, and tell me what the return value is at the end without doing any counting loop.
Now walk me through ping T step by step using that queue in plain English, no code yet. For each call to ping of T in queue in the queue, calculate the range using T minus 3000 and T. Check if current T is less than above range. If yes, DQ it. If yes, DQ it. If no, take another T and NQ it. At last, return the size of the queue. That will be the answer.
Return the size of the queue, that's exactly right, and it kills the counting loop. But there's a bug in step 3 and it's a big one. You wrote check if current T is less than the range. But T is the request that just arrived, it's always inside its own window. Which element in the queue should you actually be comparing against T minus 3000?
Okay, Q of 0. Q of 0 holds the request most likely to be expired. That should be checked and not the current end.
Correct, the front T is the newest, it can never be the expired one. Now the second bug in your stacks. You described it as a single check one if. Suppose the queue holds 1, 2, 3 and now ping of 5000 arrives, so the window starts at 2000. How many requests need to be evicted, and does one if do that?
We will use while control structure instead of if.
Yes, a while, because multiple requests can expire. In a single thing, all 3 of 1, 2 and 3 fall out at once. Last thing before complexity. State the full while condition out loud, every part of it. There's a second clause you haven't mentioned, one that starts the loop blowing up on an empty queue.
So the condition will be while queue while the queue is not empty and dq of 0 is less than k minus 3000 comma t dq the front element.
Tier 2 is thermal pizza hissing Pashchimi Afriki rain filler. Guard is good defensive instinct. But look at your comparison again. You're comparing a number to a range. You keep doing this. A less than needs a single number on the right hand side. What single number are you comparing the front of the queue against?
Okay. A less than needs a single number on the right. What single number are you comparing the front of the queue against? K minus 3000.
T minus 3000. Only the lower bound is the largest value seen so far. Nothing in the queue can ever exceed it, so the upper bound never needs a check at all. Now complexity of the optimized version. Careful, there's a while loop inside ping, so it looks like ping could be order n. What is the true cost per ping and how do you justify it?
Complexity of the optimized version. Careful here. There's a while loop inside ping, so it looks like ping could be before of it. What is the true cost per ping and how do you justify it? Think about how many times a single request can ever be dequeued. Can ever be dequeued only once, which is big often.
Exactly, each request is enqueued once and dequeued at most once. So the total dequeue work across all n pings is order n, which averages out 2 constant per call. There's a name for that. That's called amortized order 1. Say that word in an interview, and you sound like you know what you are doing. Now, what's the space complexity, and can you bound it tighter than order n?
Now, what's the space complexity and can you bind it tighter than before of it? What's the maximum number of requests that can be sitting in the queue at any one moment? One request.
No, think again. The example itself ends with 3 requests sitting in the tube. Why did you say 1? Here's the constraint that bounds it. T values are strictly increasing integers. The window spans t minus 3000 to t. How many distinct integer times can possibly fit inside that window?
Here's the constraint that bounds it. T values are strictly increasing integers. The window spans t minus 3000 to t. How many distinct integer times can possibly fit inside that window? E can be minus 3000 to 0. If it is 1, wait off. Times I said 1 because the part of the return vary.
Off by 1 again. Count the range inclusive from 0 to 3000. How many numbers 0 counts to? (3001). So the queue can never hold more than 3001 elements. That's a bounded constant independent of how many pings arrive. Space is effectively order 1, not order n. Pre-flight is done. You've got the to, the strict less than, the while loop, and amortized order 1. Now write it in JavaScript. I won't write any code for you.
One thing to think about as you write, JavaScript has no built-in queue. Whatever you use, be ready to define its DQ cost. They will use array as queue in queue operation. When happen it or will happen via queue dot push element, and then DQ operation will happen via removing queue of 0 to save on the DQ cost of big O of n. We will use a head pointer which will move on each DQ. Okay. So first, here you have got the queue, the strict less than, the while loop, and amortized big O of 1. Now write it in JavaScript. I won't write any code for you. JavaScript has no built-in queue. Whatever you use, be ready to define its DQ cost. So ping of t while the queue is not LT, steps for each call to being entered in the queue. Check while queue of 0 is less than T minus 3000. If yes, T queue is blue. First, I will do q dot push steam. Then we will calculate const difference is equal to 3 minus 3000. Then we will check while the queue is not empty. Q DGTH. While the key is not empty and difference and T is less than difference, then we do it. What I'm doing, let front is equal to 0. So when we say show it, we just move the front to 1. Front plus this. In it last, we will return q dot length minus front. Let us try run this. Sure, we have 1, 100, 3001 and 3000D. When the input is 1, the queue is empty. Okay. The queue is empty. Then we push 1 into the queue. Then we calculate the difference. T minus 3000 comes out to be minus 2,999. Then we check q dot length, it is 1, so it is not empty, and T, that is 1, is less than difference. T 1 is less than, it is not true. So front will not be incremented. So we will return q dot length minus front. So q dot length thute C. It is object dot ping. I am confused in the return statement here. Because if we are calling param1 is object dot ping t, first it is called with 1, then 100, then 3001, and then 3002. Now in this case, for each time, the queue will be pushed individual elements. So it will always wait over. So I'm confused over here. Let us copy this and give it to our AI Socratic interview. And I am a bit confused when it comes to execution of this code, that is, how will all pays be taken into consideration first.
Your confusion is the most important signal in this whole session, trust it. You've noticed something real. Let's chase it down. Look at T equals empty array. Now trace to peer clois thermal pesa hissing Pashchimi Afriki Rendinavian Leone. At the moment ping of 100 starts executing, what does Q contain?
Q contains 100.
Only 100. The 1 is gone. Every call to ping builds a brand new empty array 1 away. So ping of 100 would return 1, not 2. That is the bug you sensed. Earlier you told me the object needs to hold the requests between calls. So where must queue and front actually live so they survive across calls, and which function is responsible for creating them?
Earlier you told me the object needs to hold the request between calls, so where must queue and front actually live so they survive across calls, and which function is responsible for creating them? Look at what the problem gives you besides ping. This is the input.
Right, the very first entry is recent counter with empty arguments. That's the constructor being called once before any ping. So what belongs inside it? And in JavaScript, how do you attach that state to the object so that every p active postman and pi are relevant? Vansuleva Vandu reach it. What keyword?
Right, the very first entry is recent counter with empty square brackets. That's the constructor being called once before any ping. So what belongs inside it? And in JavaScript, how do you attach that state to the object so that every later ping can reach it? What keyword? Please start queue.
This dot queue equals array in the constructor and this dot front equals 0 alongside it. Now they persist across every ping. Rewrite it, and before you say final answer, reread your while condition against the plain English version you gave me earlier. I think there's more than one thing wrong in there.
Constructor. Check while queue of 0 is less than 10. For each call to be 10, queue in the queue, calculate the range using this. Check while queue of 0 is less than t minus 3000 PST keyword it no longer. And English condition. This is the condition. Why the queue is not empty? While the queue is not empty and queue of 0. This term of queue of right. while this.q.length is greater than 0 and this.q of front is less than difference, dequeue it. Okay. So this is the constructor listen counter.
The structure is right now, but you did not dry run it. If you had, it would have crashed on the very first ping. Look at the while line. You wrote this .q bracket front, but you declared this .front in the constructor. Inside ping, what is the bare identifier front bound to?
Okay, now let us try run 100, 3001 and 3002. Click stop. 1 is pushed. Difference minus 299. This.q.length is greater than 0. This.q of this.front is 0. This.q of 1 is less than depends 0. Then second we called 100 in case of 100. So now the q has 1 and 100. Difference is 100 minus 3000. 100 minus 3000 is 2900. So q of c1 is greater than q length is greater than 0 and this dot front is 0. 1 is less than minus the 900 work. Then we call 3001. In case of 3001, now the q has 3 elements 1, 100 and 3001. This one, and the VH is 3001 minus 3000 is 1. And here the minus 3000 this dot q 1 is less than 1 null. At last we push 3002. The request become 1, 100, 3001, 3002. Then the range becomes 2 and here 1 is less than 2. In that case, front is moved to index 1 and at last we return this dot q dot length which is 4 and this dot front is 1, 4 minus 1, 3, the answer is 3.
Out loud, Khaleshi release of Mercury ki Ririki ki Rikli Okli Miyaki Lach Versing Lansi Nicey.
Okay, ping 1, turns 1, ping 2, returns 2, ping 3001, returns 3, ping 3002, returns 10. You actually traced rather than copied at the moment ping 3002 returns What are the exact values of this dot q dot length and this dot front? This dot q dot length is 4. This dot front is 1. Okay, that's a correct accepted solution. Let me review it honestly. Correctness passes NQ, then evict ordering is right. Less than is right. While is right. This dot street is right. Complexity amortized big of 1 per ping. Space is big of 1 bounded by 3001 live entries, but your code doesn't actually achieve that. This is the one real flaw left. To never remove elements from this dot queue, you only move this dot front forward. So after 10,000 pings, how many elements are physically sitting in that array?
He 10,000 elements.
Right, so your space is actually big O of n, not big O of what. That prefix is never reclaimed. He bought amortized big O of 1 DQ at the cost of unbounded memory growth. That's a defensible trade-off at n equal to 10 raised to 4. But an interviewer will ask, what would you do if ping ran for hours? Name one piece. Instead of arrays, I will use linked list for queue implementation. Worth knowing there's a cheaper trade to periodically splice off the dead prefix once this dot front grows past some threshold. Same effect, no new data structure, either answer passes. Here's the honest reviews. Score 7.5 out of 10. Let me submit the LeetCode problem. Okay, it is passing. Let me submit this. Okay, and we are done. So all test cases are passing. 68 of 68 test cases passed. This is our implementation, wherein we are using an array for queue implementation. We push the elements into the queue, then we calculate the difference while the queue is not empty, and the front of the queue is less than difference. That is the case. We remove or advance the front in this case. Then at last we return this dot q dot length minus this dot front. So thank you all for watching. This is how one has to struggle by solving a DSA problem in an interview. So struggle is part of the learning. Keep learning. Take it one day at a time. Hope you have liked this video. If yes, please do like, share and subscribe. Thank you.